All right, for our first example problem of this material, we have two blocks here, and we want to find the magnitude of the force that the objects exert on each other and the net force that each object experiences. So we just talked about Newton's third law, so we're going to put that into action here as we analyze all of the forces on this system. So the first thing we're going to do is look at the entire system as a whole and get some information down. So if we look at the net forces on the entire system, what are those forces? Well, we can see we have two. We have this 5 Newton force pushing to the right and a 3 Newton force pushing to the left. So we have 5 newtons in the positive direction and minus, because the other one is pushing left, 3 units in that direction. So this gives us 2 newtons total for the net force on the entire system. Now we can look at each object individually and look at the net forces acting there. So let's look at object 1 first. So the forces acting on object 1, well, this 5 Newton force is acting directly on object 1, so we have positive 5 there. And then we have this contact force that we talked about in the last video. Block 1 is being pushed up against block 2, and that means block 2 is pushing back against block 1 with some force. So we'll denote this as the normal force. And what direction is this going? Well, block 1 is pushing against block 2 this way. Let's change back to green there. So we know that block 2, by the third law, Newton's third law, has to be pushing in the opposite direction with equal magnitude. So it's pushing left, and we'll denote this as the normal force of block 2 on block 1. All right, now let's do the second block. So the forces on block 2, well, first off, we have this 3 Newton force pushing directly against the second block in the left direction, so that's going to give us a negative 3. And then we also have the normal force of block 1 on block 2. And since block 2 is pushing to the left against block 1, we know that block 1 has to be pushing to the right against block 2 by Newton's third law. So this is going to be plus the normal force of block 1 on block 2. And Newton's third law tells us that these are equal and opposite forces, and we've captured that here. So this is opposite direction of this one, and even though we denoted them differently to clarify what object is acting on what, the magnitudes of these are going to be equal. Okay, so now we have our net force and the objects and the forces on both of our objects, and you might think, oh, well, we could get some more information by adding these two equations together and setting it equal to the net force, and that will give us a true equation, because the entire system consists of object 1 and object 2. So if we add them together, that should give us the net force. And let's see what we can find from that. So we know that F net is equivalent to the forces on 1 plus all the forces on 2. And if we make the substitution, we know that F net is 2. So 2 equals, what are the forces on 1? Well, 1, all the forces on object 1 are right here. So we have 5 minus normal force of 2 on 1. And then all the forces on block 2 are here. So we have minus 3 plus the normal force of block 1 on block 2. Now, by Newton's third, we know that N12 and N21 have the same magnitude, and since they're pointing in opposite directions, we can just cancel them out. But then what are we left with here? We're left with 2 equals 5 minus 3, which not only is obvious, but we already came up with that. That's just this exact equation. And sometimes this happens. Sometimes you set some stuff equal to each other, and in this case, this was correct, but the information it provided was just not useful. So let's see if we can use something else. So we go back to our problem, and we notice that we have the masses of these two objects that we haven't made use of at all. So can we find the forces that we're looking for by utilizing the masses? And so we can using Newton's second law. So we're going to bring the second law into this. And remember, Newton's second law was that net force on an object is equal to the mass times the acceleration. So let's use that across these same three categories. So first, on our entire system, so F net equals the mass of the entire system, which is 1 plus 3 here, that's going to give us 4, times the acceleration of the entire system, but we already know what the net force is. We added that up earlier. It's 2. So we can just go ahead and substitute that in. And this gives us that the acceleration on the entire system is going to be 0.5 meters per second squared. And this is useful because the acceleration of the entire system is going to also give us the acceleration of each individual block, because the system is made up of the blocks, and that's going to help us with this next couple pieces. So let's slide this down, and now we're going to look at the first block from Newton's second law perspective. So the forces on the first block should be equal to the mass of the first block, which is just 1, times the acceleration of the first block, which we know now is 0.5. So this is already simplified for us very easily. So the total force on block 1 is 0.5 newtons. And so we can sub this value in right here, and that will give us this normal force. So let's do that. So if we just take this equation down here, and then we just make our substitution, F1 we know is 0.5, then this gives us the normal force of block 2 on block 1. The magnitude is 4.5 newtons. 4.5 newtons. Now, we could go a couple different ways. We could say, oh, well, since we know that the magnitude of 1 on 2 is the same as 2 on 1, we could sub that in directly and solve for F2. We could do that, but let's continue with the trend here. We already used Newton's second law on the system. We used Newton's second law on object 1. Let's go ahead and use Newton's second law on object 2. So by Newton's second law, F equals ma, the forces on object 2 are going to be the mass of object 2, which is 3, times the acceleration of object 2, which is 0.5, we know. And this just simplifies down to 1.5 newtons. And now we have all the information we were looking for. The total force on object 1 is 0.5 newtons. The total force on object 2 is 1.5 newtons. And the total force on the system is 2. And the force that each object exerts on each other is 4.5. And if we kind of take a look here, the gut check, this passes the gut check as well. Since we have a positive force on each of our objects and on our system, then we should have a positive acceleration on each of our objects in our system, and we do. So just a quick little intuition test to make sure everything makes sense, and it does.